Guys, today we're going to do a lesson on algebraic expressions. So the last information that you should have in your notebook is page 104 and 105. Today we're going to be adding information to pages 106 and 107. Before you start, I do want to point out that you're going to need a couple of things today. You're going to need some colored pencils, you're going to need a regular pencil, and then you're going to need a copy of this handout from the teacher. You want to make sure that you cut it out. So as you can see, I've cut mine out. It is double-sided. You might notice that the lines don't exactly line up, but it's okay. It'll work out. So if you want to pause the video while you go ahead and get all of that stuff ready and then restart whenever you're ready to go, that's fine with me. We're going to start on page 106 today. We're going to title this page Numeric and Algebraic Expressions. And today we're going to take a little bit of time to look at what are numeric and algebraic expressions. We're going to start by defining those two things at the top of the page. Numeric expressions are exactly what you might think that they would be, so let's start with that. Obviously, the background or the root word for numeric expression is number, so this is a math sentence, or you might hear it called as a math statement that includes numbers and operations. So if you want to write that down, go ahead and pause if you need to and get that part down. And then a real good example is any of the order of operations problems that we've been working on over the last several days. So it would be something like this: 6 plus 7 times 3. Notice I have multiple operations. I have a multiplication, I have an addition, and then I have all numbers. We're also going to branch off a little bit today, and we're going to talk about algebraic expressions. And an algebraic expression is very similar to a numeric expression, except instead of having just numbers, this is a math sentence that includes numbers, operations, and variables. So it might look something like this: 7 plus a times 6. So notice this also includes some operations, but we also have this variable thrown into the mix, which means we can't solve it quite as simply as we can with the numeric expressions up here. So at this point, you're going to need your handout that you were given, and we're going to use this as we work through and review what you should have seen in your previous video. We're going to take this paper and we're going to turn it over like this, and then you're going to flip it over, and what we're going to do is we're going to color code all of this information as we work through it. So we're going to start with this example, and the very first thing that we're going to do is we're going to talk about each of these things. Now you should have seen this in your video, but we're going to start with coefficient. In your video you learned that a coefficient is a number that is together with a variable. And of course, I do expect you to be writing this onto your own paper as I'm doing it. And remember that this means that you need to multiply. The variable is the symbol, and traditionally we use a letter. Now, that doesn't mean that you can't use a star or a heart or a smiley face in the place of the number, but traditionally it's a letter, and that stands for a missing number. So again, remember, if you need to pause and rewind, whatever you need to do. Operations we talked about are the math steps that you take. They include addition, subtraction, and I'm just going to abbreviate, multiplication, again, I'm going to abbreviate, division, and then, of course, we also have parentheses, which we know is just a grouping symbol, but they have to have one of these within them, and then exponents, which are actually repeated multiplication. And then the last thing that you have to know about is called a constant. A constant is a number that stands alone in an expression, and that means there's no variable with it. Okay, so make sure you have that information in your notebook on this little paper. We're going to take the example problem that they gave us, which looks like this, and we're going to write it right here. So you're going to see me write it very big. So that it looks like this. Now notice that my X looks a little bit fancier than a traditional X, and that's because when we have algebraic expressions, that X could be confused for a multiplication symbol, so we want to be very sure that whoever's reading it knows that this is actually a variable, not a multiplication symbol. Now we're going to use those colored pencils that you had, and we're going to color code each of these things. So the first thing that we're going to look at is this coefficient. So I'm just going to grab a colored pencil, and I'm going to color code this, and I'm looking for a coefficient. And a coefficient is a number that is together with a variable that means for me to multiply. So what I'm going to do is I'm going to come down here, and if I'm looking for a coefficient, it means multiplication. Well, there's no multiplication here. I know that this means to multiply. The coefficient is the number that goes with the variable. So that means that this 3 is called a coefficient. So I'm going to color code that the same color that I color coded the word coefficient at the top. So if you want to take just a second and do that, then you go right ahead and pause if you need to. I'm going to continue this process. I'm going to get another colored pencil, and I'm going to color code the word variable. Your colors don't have to be the same as mine. I don't know if I said that or not, but you feel free to do whatever colors you want to do. If I'm looking for a variable, I'm looking for a symbol, traditionally a letter that stands for a missing number. So when I look at this problem, it's very clear to see that the variable in this problem is the X. So there's my color coding for that part. The next one that I'm looking for is an operation. And technically I have two different operations in this problem. I have a multiplication, which is here, and that's kind of an unstated operation. The most clear operation is this one here, which is your addition symbol. So I'm going to color code that one. And then I'm going to grab another color, and I'm going to look for a constant. And a constant is a number that stands alone. It's not in a coefficient setting. It stands all by itself, so that means that this is my constant. So there's the basic things that need to be color coded. Now, the last thing that we're going to talk about today is called a term, and that's down here at the bottom of your paper. So a term is basically a combination of coefficient with a variable, okay, or a variable on its own or constants, which are just those numbers, remember, that are separated by operations. So take just a second and write that down. But this means that you have either combinations of things that work together, or you have things that stand on their own and they are all separated by operations. So if we look at this problem, I'm going to take one more colored pencil and I'm going to look and see how many terms this one has. This example has 2 terms. This is the first term. Because this works together as one functional part. The 3 is the coefficient that goes with the variable of x. I cannot separate those. And then here is a second term. So this is kind of like saying how many parts does this problem have. This has 2 parts. The 3x is a part and the 4 is a part. So I'm going to color code this word right here, term, in purple so that it matches with my image. The algebraic expression we've already talked about. If you want to recopy what we had in your notebook here, then you certainly can and put it here in your notebook. What we're going to do with this now is we are going to do exactly what the instructions tell us. We're going to fold here on this line. And then we're going to fold here on this line. And then you're going to take your scissors and you're going to cut each of these. And when you do, each one is going to be its own separate piece of the puzzle. And then they'll all tuck in to, it's kind of like a matchbook for anybody who knows what a matchbook is. They all tuck in here, and then you can just put some glue on the back of this, and then you glue it right onto page 107 of your notebook. Nope, I'm sorry, that's not 107, that would be 106. Okay, great, thank you.